Okay, this is the first attempt to develop a new automotive specialty within the ITESM Monterrey. And basically the main idea to present today is different modules, different ECUs from the automotive, from the main users interface. We have the air conditioner, the HVAC. We have safety features around here. Also, we have a lighting system, so the body controllers, simulation of the powertrain. Finally, we got also the cluster design. Okay, I will let the team to talk about each of their own modules. Okay, so team.
We receive the CAN messages from most of the models of the car, and we show these indicators, for example, the velocity, the revolutions, temperature, fuel level, and some safety indicators for the doors and the belt. We have an interruption that receives all the CAN messages from the modules. And then in the main routine, we send with the SCI the messages to LabVIEW, which grabs the values.
Hi, we developed the user interface. We send the message of the HVAC and the lights control. For example, the HVAC is off. Turn it on. We control the velocity, the temperature, and the position.
The HVAC module functions receiving message from the user interface. They can control the velocity of the fan and the position of the stepper motors, which control the flux of air depending on the temperature and the position that the user wants. Pretty much that's all, and we control this with the Cusco microcontroller.
We developed a light system. We receive messages from user interface, and we display all the lights, main lights, buzzer lights, DVB, stop lights, and reverse lights.
Okay, what is that?
It's a stop.
Stop light? Stop light? Direccional. Okay. Okay. Okay.
Safety part of this project, what we did is that we detect when a person is seated, and we advise the person to put the seatbelt, and if he doesn't, we have a beep like this, and it should show on the cluster some signal that shows that he is not. You can see it. Then it beeps till you click it or tick it. Good, now you're ready to drive. And you're safe, buddy. You're safe. And then it beeps. Shuts up. Oh well, and if you stand up, it beeps as well, you know? So you have to stay seated.
Okay, we are the part of the team assigned to the part of the doors in this car. Well, our circuit functions the following way. From the ignition key, we receive a signal that goes through CAN to our MCU. There in the MCU, it has programmed and a slave card. This master card manipulates two slave cards. Each of these slave cards is for one of the doors. We can detect if the door is open, if it's closed. We can send a signal so that the window can go up and can go down also, and that signal will be reflected on the cluster there in the computer.
Okay, so if we open this door, we can see on the cluster that it's open, and if we close it, we can see on the cluster that it's closed. And for the signal, we can go the window up, and we can go the window down. And also we simulate the lock with this LED. So if we lock the door, the LED is on. When we lock the door,
¿Lo quería ahora sí abrirlo otra vez? ¿Sí, no?
It consists in a nitro engine where we measure and control temperature. Also we measure RPMs and velocity of the vehicle.